Hey pre-calc students, today I'm going to go over how to find all the real zeros of a function. So take a look at this example for number 1. It says f of x equals 2x cubed minus 5x squared minus 2x minus 5. It says you may use your graphing calculator to find one factor of the zeros, okay, or aka one of the zeros. Yep. Now, it's a cubic. So if we can find a zero from the graph, we can use synthetic division to break this cubic down into quadratic, and from there we can solve it by using the quadratic formula or by factoring. So I'm going to take a minute and type this into my graphing calculator. So essentially, my steps are these. I am going to type the function into my y equals. Secondly, I'm going to graph it. And then thirdly, I'm going to look for the zeros, aka intercepts or solutions. Now, this is the step that you're going to have to confirm. So you're going to have to confirm this, and I'll explain what that means in a second. All right, so pause the video. Type in that function of 2x cubed plus 5x squared minus 2x minus 5 into your graphing calculator. Push play when you finish. Okay, so I typed in 2x cubed plus 5x squared minus 2x minus 5 into my graphing calculator, and I'm going to graph it. It's a cubic. Notice that it hits the x-axis 3 times. So it's got 3 zeros, 3 real zeros. Now, the way that I have my graph set up, I used Zoom Standard, so Zoom 6. So my graph goes from -10 to +10 on both axes, x and y. Each tick mark is 1. So what I can tell is that this function intersects the x-axis somewhere between -2 and -3. It looks like it intersects the x-axis exactly at -1 and at +1. So I am allowed to use any one of these zeros to start my synthetic division, but I need to be sure about the number that I used. So let's say you think this is -2.5. You need to confirm that by using second trace or by using the table. Now, I tend to gravitate I tend to use zeros that are not decimals if possible. So I'm going to try to see if -1 or +1 are zeros. So I'm going to see if I can find them on the table. So I'm going to go to second graph, and you can use your arrows. See, I set up my table to include the halves. So to do that, I did second window, and I said, okay, you should, if you want, have this always set to start at 0, the table to start at 0, and then this little triangle that says TBL, that's asking you what you want your table to count by, what increments. So I have it at 0.5. Most calculators don't have this, so your table might be set up to count by ones. So I'm going to go back to second graph. You can see my table, and this is probably how your table showed up. It had only whole numbers, but you can definitely adjust it so that it counts by half. So if you go back to second window, you can change your, it's called delta. So delta table, that's what you count by. You can count by halves. So now if I look at my table, I can see that -1 is a 0 because it's paired with a 0, -1, comma 0. The other one, remember I said it looked like it was between -2 and -3. There it is, -2.5. -2.5, comma 0. What else is a 0? -1, 0, and then +1, 0. Okay. So I am allowed to use any one of those zeros to begin my synthetic division. I can use -2.5, -1, or +1. I encourage you to try to use the whole numbers when possible. Now, let's say I decide to use -1. Okay, that was a 0. So set up your synthetic division. And we are going to do synthetic until I end up with a quadratic. So we started with a cubic, we're factoring out a zero, a linear zero, so we're going to end up with a quadratic. So carefully do your synthetic division. Remember, you multiply and then add. You multiply the bottom row with the zero and then add. Then multiply your bottom row with your zero. This is your zero over here in the little box. And your last column should be a remainder of zero because you specifically looked at your graph where your polynomial intersected the x-axis and you saw that it intersected at -1. Remember, if something is a factor or a zero, then the remainder when you do a division should always be zero. So this is my quadratic. Now I'm going to either use the quadratic formula or factor it if possible. Now, if you can factor it, great. If you can't, then you're going to have to use the quadratic formula. Now, this can be factored. There are two numbers that multiply to -10 and add to 3. So some of you guys tend to use this little x. I know Miss Wilson and a few other teachers did it that way. So I need numbers that multiply to -10 but add to 3. So I can use 2 and 5. But the 2 would have to be negative. So this strategy of factoring is called splitting the middle or factor by grouping. Okay, take the GCF of the first 2, take the GCF of the second 2, and then you're essentially doing backwards FOIL to find out what needed to multiply, right? So check it out, 2x squared minus 2x plus 5x minus 5. That gives me those 4 terms. If you need help or review on factoring, check Google Classroom because I've posted quite a few videos on factoring. Okay, and then all you have to do is solve these by setting them equal to 0. Feel free to show the work or not, it's up to you, but you're individually setting them equal to 0 and solving. Okay. Now remember, we already saw on the graph in the graphing calculator that this function appeared to intersect the x-axis at -2.5, -1, and +1, which is exactly what we got as our solutions. -2.5, -1, and +1. So again, whenever they ask you to find all the real zeros and to use your graphing calculator to find one of the zeros, pay attention to where your polynomial intersects the x-axis. Okay, now for number 2, they're asking the same question. Find all the real zeros. You may use your graphing calculator to find 2 of the zeros. So now we are starting with a quartic. So you're going to work with your quartic, do synthetic division with 2 of the zeros that you find on your graphing calculator until you get a quadratic. Then you can solve it by factoring or using the quadratic formula. Pause the video, type this function into your graphing calculator, and you're going to repeat the steps that we did for problem 1. Type the function into y equals, graph it, and look for where the function intersects the x-axis. Push play on the video when you are ready and have already graphed the function. Okay, so this is a quartic function. Just by looking at the graph, it looks like it intersects the x-axis at -2, +1, and then there's these decimals that don't really look like they're halves. So when I look at my table, second graph, and I want to confirm which ones are the zeros. Okay, so remember, go back to your graph. It looks like it's -2, +1, and then these are iffy. It's hard to tell where it hits the x-axis. It's somewhere between 2 and 3, 2, 3, 4, 5, 6, 7, and somewhere between 7 and 8. So I'm going to avoid these 2 for my synthetic division. I want to try to pick the nicest numbers possible. So I'm going to see if -2 and +1 are zeros by going to second graph and seeing if negative 2 is a 0. Yes, it is. Negative 2 comma 0. And positive 1. Positive 1 comma 0. So you're confirming on your table that those are zeros. Since they are zeros, I can use synthetic division with either one of those. Oops, I already forgot which ones they were. Negative 2 and positive 1. So I'm going to write those down. Negative 2 and positive 1. And I'm going to use those for my synthetic division. So I'm going to start with the negative 2. It doesn't matter which of those zeros you start with. Now remember, for synthetic division, you want to fill in any missing terms. So with a quartic, you should have a cubic, quadratic, linear, and constant. We have one of all of them, so we're not missing any. So the process is bring down the first column. Now you multiply that bottom row with your 0, and then you add, then you multiply, then you add, then you multiply. Oops, something went wrong over here. Let me try it again. Let's see, negative 2, 7. It's so important for you guys to always double check. Oops. Let me see. Cubic, quadratic, linear. So this should be a 0 at the last column. Let me try to find my mistake. Oh, I found it. It's negative 58, right? Negative 2 times 29. Good. Okay, we got to be careful with our work. So negative 58 plus 39. Now we're talking. Now I'm going to have a remainder of 0. So that's the nice thing about these types of problems is if you don't get a remainder of 0, you know that you messed up somewhere. So that's why I took a break. I double-checked my work. I noticed that I forgot a negative, and now it works out perfectly. So it should have a remainder of 0. Now I'm going to use those same coefficients and continue on with the process. So we started with a quartic. Now we have a cubic. And we already used the 0 of negative 2, so now I'm going to use positive 1 and repeat the process. The directions said that I could use 2 zeros, so I already used one of them. Time to use the second. So bring down your first column. Now remember, carefully make sure that you're multiplying correctly and adding, right? And that last column I had forgotten a negative. Super sad. I tend to find that if I do, oops, that should be a positive. I tend to find that if I do important things at the end of the day, after a long day, I tend to make more mistakes. Same with if I try to do it in the morning. So try not to do your homework at 11 p.m. at night. You're probably going to make more mistakes than normal. All right, so now I've got a quadratic, and all I have to do is ask myself, how do I solve this? If you remember, the other 2 zeros on the graph were decimals between 2 and 3 and 4, 5, 6, between 7 and 8. So what I'm going to do is I'm going to ask myself if this could be factored. If it can't, I'm going to go ahead and use the quadratic formula. So I'm going to find the discriminant, b squared minus 4ac. That's kind of like side work, b squared minus 4ac. I get 24. That's definitely not perfect, okay? So I'm going to bring this up here. I'm trying to solve it. So x equals the opposite of b plus or minus the square root of b squared minus 4ac, which is your discriminant, all divided by 2 times a. A was 1. All right, break down your root. So that's square root of 24 is square root of 4 times square root of 6, so that's 2 root 6. And then simplify. So 5 plus or minus 1 root 6. Now, pause for a second. 5 plus root 6 is 7.44. It's between 7 and 8. So remember in our graph that the quartic intersected the x-axis somewhere between 7 and 8. And then on my calculator, if I put 5 minus root 6, I get 2.55. So if I look at my graph, the quartic intersects the x-axis between the 2 and the 3. So those answers make sense. That makes me feel like I did my quadratic formula correctly. All right, I wrote kind of big, but the zeros are -2, +1, and then the conjugates 5 plus or minus root 6. Okay, hopefully this helped, but if you still have questions, feel free to send me a message on Reminder, email me. All right, have a good day.